Hi, welcome to the Oliveboard platform. Today I'm here to discuss the topics of cubes and cuboids in very brief with you. Okay, cubes is something which I have discussed in a lot of sessions in the past also. I'm not here to give you any theoretical understanding, but I'm only here to solve very limited questions. But these questions are not your average regular questions. They are very different questions picked up from very unique sources, right? The only idea is to give you exposure as to what sort of questions can you expect, and even if you don't expect, how to tackle it generally. So let's quickly start. For cubes, I will not give you a lot of explanation, but the questions are not your regular formula based questions. These questions of cubes are all observational, and for the sake of understanding, I have given you a figure here which I would want to eliminate as of now. I don't know how much of that can I do. Is it yeah, okay. For now, let's just remove that. Let's see how will this work in our favor. So if we have this question, okay, a cube of side 10 centimeter is colored red with a 2 centimeter wide green strip along with all the sides on all the faces. The cube is cut into 125 smaller cubes of equal size. So one thing we know is the value of n cube is 125. So we know that n is equal to 5. That means there are 5 cubes along the length, breadth and height. Okay. And answer the following questions based on this. So the question is this: how many cubes have 3 green faces? Anyways, this question did not need the figure. So I could have given the answer 8 right away without the figure. But this is where I would need an answer of the figure. How many cubes have at least one face colored? Now, the problem is, even if I say one face colored, this will not be a problem for me. But if I would give you a question, let's say I'm giving you a question myself, that how many cubes have green colored faces only, or how many cubes have red colored faces only. Idea is for you to understand that how will you actually tackle this figure, because this figure is not given in the exam. I have just added this figure for your reference. So a cube of 10 centimeter is colored red with a 2 centimeter wide green strip. So the whole cube will be green, will be red, and there will just be a single green width on the outer end. I'll just show it to you now. This is exactly what I'm talking about. Okay. So this is how your cube is looking like. And we have n equal to 5. So you can see 1, 2, 3, 4, 5. 5 along the length, along the breadth, along the height. Now I had asked you how many cubes with only red faces. So now you can clearly identify that I have 3 and 3, 9 red faces on one face. And I have 6 such faces. So I will have 54 red faces. Or if I ask you how many green faces are there, so you will count how many green faces, how many green cubes are there. Okay, so we have 5, 10 and 6, 16 on this end, 16 on the other end, and here we have 3 and 3, 6 and 3 and 3, 6, so 12 again. So 27 plus 12 is 39. 39 cubes with green color only. So these are the kind of questions for which you will need the figure. Okay, for now I think how many cubes have 3 green faces? We have already given the answer is option B, 8. And how many of them will have at least one face colored? Okay, so we are looking for at least one face. Now what are the possibilities of colors being there? We have either no face painted or one face painted or 2 or 3. Maximum 3 faces can be colored, right? My question is saying at least one face. So minimum one face should be colored. So 1, 2, 3, all of them will be included, but this will not be included. I know the total is 125. Okay, I can find out how many cubes will have no faces colored. So it is n minus 2 whole cube. Correct? N was 5. So I will say 5 minus 2 whole cube. That is 3 cube. That is 27. I will subtract 27 from 25 and I will end up getting option A, 98. What have I done here is I have just subtracted no faces painted from the total. So I will only be left with the sum total of 1, 2 and 3, which is precisely what I had to find out here. Now this is an understanding. This is not a regular question. This is not a direct question. Okay. Let's look at the next one. The next one also, if I just remove the figure, this figure actually was not given in the exam, in the question I mean. Wait, what's wrong? Yeah. Okay. So a cube whose two adjacent faces are colored is cut into 64 identical small cubes. Okay. And how many of these small cubes? So I know n cube is 64. So n is 4. This is something which I can find out right away. How many of these small cubes are not colored at all? Assume that the top face of the cube and its right side are colored green and orange respectively. See, the question is trying to tell you, generally if you would have approached this question, if you were only looking for 0 faces painted, your answer would have been n minus 2 whole cube. But this is not that. This is saying only 2 faces are colored. Okay, one is orange, one is green. Apart from that, everything is uncolored. Now you have to find out how many are not colored. So this again has to be visual. How will you generally solve this? What will you do is you will assume a cube here, something like this. And when you know n is equal to 4, so you know 3 lines like this and 3 lines like this. This is how the top face will look like. Okay, this is how the top face will look like. And let's say I'll put 2 colors. Let's say orange, somewhere at the bottom I'll have the orange color and somewhere at the back let me have green color. Just for the sake of it, I'm doing it so that I don't have to count it. Now I have to count the other faces. Okay. So obviously I'll not count this layer at the back because of the green cubes, and I'll not count the bottom layer. I'll out count these layers 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. This will also have up to an extent, this will also have some. So I will only count those many figures at the back and I'll end up getting my correct answer. Okay. So let me show it to you in terms of a figure also now. That will make it easier for you. So this is how the figure is looking like. Okay. Now we need to count how many cubes will not have any color. So see, even this line which you see here has color on the top. Okay. And this line which you see here has color on the side. We will be counting these figures. How many cubes are there? 9 such cubes. Okay. Like we had counted. And these 9 cubes in layer 1 are colorless. In layer 2 will be colorless. In layer 3 will also be colorless. Okay. And in layer 4 will also be colorless. These 9 cubes will not have color anywhere. Will they have? No, I don't think so. So the answer is going to be 9 cubes into 4 layers, which is 36. Option D is the correct answer. Because green and orange are only on the top and side. They are not there also. There also it is uncolored. Cool? Good question. See, next one. This is a cuboid now. For cuboid, I have to give you some instructions. Okay. So for a cuboid, you will just modify the cuboid a bit from a cube. So supposedly, I am talking about a cuboid. Let's say so this is my cuboid. Okay. Now I am cutting this cuboid into various dimensions, but the idea is n for the cube was number of cubes along the length, along the breadth, along the height. They were always equal. Here they will be unequal because the length will be different. Okay, the breadth will be different and the height will be different. So we'll have L, B and H here, and we'll have NL, NB and NH here. Which are what? Which are length of the, let's say the length of the square is A. So NL will be equal to L upon A, length of the cube. NB will be equal to B upon A, and NH will be equal to H upon A. That means the length of one cube and the length of the total cuboid. Total cuboid divided by one cube, because they will always be cut in cubes only. They will always be cut in smaller cubes like this. Okay, smaller cubes. So there are, what is the n here? It is 5. 5 along the length and 4 along the breadth, along the height. Can you see? So this is how a cuboid works. So what are the formula for cuboid? The formula for cuboid will also change accordingly. So I'll just show you the formula right away. We'll have 3 faces painted. So there will always be 8 cuboids again, 8 cubes, the corner ones only. That is still the same. Corner ones will have 3 faces painted. So that is no rocket science. If we have 2 faces painted, the formula is 4 into NL plus NB plus NH minus 6. If you have 1 face painted, the formula looks like a total surface area. So we'll go with 2 into NL minus 2 LB, so NB minus 2 plus BH, so NB minus 2 into NH minus 2 plus LH, NL minus 2 into NH minus 2. This is how your formula works. 2 into LB plus BH plus NH. Instead of L and B, we'll write NL minus 2, NB minus 2. Similarly, for 0 faces painted, it looks like a volume of a cuboid. So L into B into H, instead we'll have NL minus 2 into NB minus 2 into NH minus 2. How many number of cubes? Number of cubes there in case of cubes, cutting cubes into smaller cubes was n cube. Cutting cuboids into smaller cubes will be NL into NB into NH. Okay, so this is how you solve questions of cuboids. If at all they come across, they will not be very difficult. And if it is manual, then you know how to solve it as it is. So for the formula, I am teaching you this. And remember, this is all for multi-layer cuboids. This is not for a single layer cuboid. For a single layer cuboid, because a single layer cube does not exist, but a single layer cuboid can exist. That means instead of all these layers, I could only have one layer like this. That's it. This is a single layer cuboid. Just giving you a rough example. Okay. This is how a single layer cuboid looks like. So in that case, if they ask you how many cubes have 4 faces painted, some of you might answer 0. No, that's not true. So this here, this cuboid at the corner, we'll have painted at the bottom also 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So again 4 will be the answer with 4 faces painted. And for 3 faces painted, you will have to manually calculate now. It will not be 8 by default. Just understand this is a small variation which they may put across. So I'm catering to multiple examinations at this stage. Okay. So now we'll come back to this question. After our brief revision, we come back to this question. The question says that there are the cuboidal block. It has 4 centimeter length, 5 centimeter breadth and 3 centimeter height. And if you look at the figure, along the length you have 1, 2, 3, 4 cubes with 4 centimeter. That means the length of one cube is 1 centimeter. Okay. And we have L equal to 4, B equal to 5 and H is equal to 3. So NL, NB and NH also will be 4, 5, 3. The question is trying to ask me that how many cubes will have only one face painted. So the formula of one face painted is as per the cuboids, as per the surface area of cuboid, total surface area, 2 into NL minus 2, NB minus 2 plus NB minus 2, NH minus 2 plus NH minus 2, NL minus 2. Okay. And we know NL is 4, 4 minus 2 is 2, NB is 5, 5 minus 2 is 3 and NH is 3, 3 minus 2 is 1. So this is 1 into. So what is the answer? 2 into 3, 6 plus 3 plus 2. So 11 into 2 is 22. Option B should be the correct answer. And even if you look at the figure, if you want to look at the figure, okay, so how many will have only one face is painted? So you will see 1, 2, 3, 4, 5, 6, 6 on the top face. Okay, 6 on the top face, so 6 on the bottom face, 6 plus 6, 12. And if you look at the second layer here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 at the middle layer. So 22 in all. This is how you manually count it. But you don't have to do that because you know the formula. Okay. And the last question is a very interesting question. Right? Very popular question in cuboids in a lot of difficult competitive exams. So you should have this exposure if you really want to get good at reasoning. Now this question says that I have, again the figure was not given, but I have made it here so that it's easy for you to understand. So there is a cuboid, a cube which is cut into smaller, cubes. A large cube cut into smaller cubes. Have 125 smaller cubes are arranged in the form of a cube on a table. So you can pick up a cube and cut into 125 smaller cubes. So n cube is 125, n is 5 for me. And if you observe, number of cubes along the length, along the breadth, along the height, they're all 5. So this is how they have arranged it. Now what they're doing is they are removing the corners. So this corner is completely removed. This corner from the pillar, this pillar and this pillar, they are completely removed. So this figure has been obtained now and it is completely painted red on the outside, but not at the bottom. So every time they are giving you a new situation now, it will not be able to solve it with the help of formulae. It has to be observational. So now they are painting it red across the cube except for the bottom. This is how it looks like. Okay. Right? The question is trying to ask me how many cubes do not have any colored face. How many cubes do not have any colored face? Instantly, a lot of people think about the bottom face only, but that's not true. If you observe carefully here, I'll just show it to you in white marking. Look at this one. This cube here, this, this. So just look at these 9 cubes exactly in the center. Apart from that, all these cubes outside, they are all colored. At least one face is colored. For these 9 cubes, the first layer, layer 1 is okay, but layer 2, layer 3, layer 4 and layer 5 also, because the bottom is also uncolored. So inside all these cubes, layer 2, 3, 4 and 5, below these cubes here, these 9 cubes in 1, 2, 3, 4 layers will all be uncolored. So the answer comes out to be 36. I have just put one question here, right? So this is how we solve these questions, but it's all observational. There is no rocket science here. There is no formula whatsoever. This is just pure practice. So if you pick up such questions and if you just try to solve them, you will get better at this. But where can you find such questions of various topics? Well, I will clear that also for you right away. So if you just log into the Oliveboard website. Okay. By the way, it has completely, the interface has changed for all of you. So when you log into the website, in the drop down here, select SSC. Okay. And then select tests here in the left side. Tests. Click on CGL Tier 1. And you just scroll downwards. You will get this. Super practice PYP 1000+ tests. Beginner, expert, most repeated questions, speed, revision test, everything. Click on view. Okay. So this is the page which will open up for you. Click on reasoning. And look at the topics here. Analogy, odd one out, similarity, series, coding, decoding, Chinese coding, mathematical symbol, word based, logical order, dictionary, matrix number series, inequality, blood relations, direction, syllogism, puzzle arrangement has 3 sets, ranking, positioning, data sufficiency, visual reasoning means non-verbal reasoning, dice, cube. Everything is in these 5 different topics. Venn diagram, critical reasoning, clocks and calendars, word matrix, reasoning, input, output, what is the function. Everything is here. Pick up one random topic. Let's say I pick up coding, decoding. Okay, and I can see various level. There are 6 different tests under coding, decoding. Level 1 is easy, this is medium, this is hard. These are previous year questions, this is speed improvement, this is revision. Everything at one place. If I just click on take test here, and if I just click on start test here, this is how it looks like. Okay, 20 unique questions of coding, decoding. Just go through the questions. They are extremely of wonderful levels. And they will help you practice everything at one place. These questions are not repeated questions. Repeated means they have not been taught in your regular sessions. They are unique questions picked up from various previous year exams. We have seen as a trend how many question types are repeated, and from that this complete super practice set has been generated. So go ahead and utilize this for your complete benefit. And for now, I'll end this session. I told you it was a very brief session, only for me to give you an exposure to cubes and cuboids, right? So you see the logic actually is very vast, and you can actually study a lot in terms of cubes and cuboids, which is generally not asked in SSC exams, but it is not completely removed from your syllabus. Anyways, thank you so much for watching live till here, guys. I'll see you around in the next session. Till then, you guys take care. Bye-bye. Namaskar. Jai Hind. If you're new on the platform, hit the subscribe button right away. Like the video and share it across platforms. See you guys.